Okay, so this question is not in the notes. However, I felt like adding an extra problem as an example. So last time we had a problem where there was some wall and some beam was exerted outwards from the wall, and there's a rope that was holding it up. And we were trying to solve for what was the tension in the rope. So now we're going to flip it around a bit. Now we're going to say what happens when the beam itself is angled. So in this case, we have some type of base, and we have some upwards pole. You'll actually be doing this in the lab yourself, just to test it out and to prove this as well later. And from here, we're going to have like a ruler or something with mass just extended outwards like so. Okay, so that is beam, and it's just kind of resting against that corner right down here. And lastly, from here, we're going to have a rope that is going to be connected to that beam. At the end, we're going to attach a 200-gram mass. And let's give us some dimensions. Let's say we have 0.43 meters and 0.57 meters from here to here. So 0.43 from here to here. And if we think of this as a meter stick, so from all the way from one end to the other end is 1.00 meters. And lastly, the distance from here, we can say is 0.71 meters. So let's go ahead and draw our forces. So what forces are acting on? We know there's this mass hanging at the end, so there's one force. There's the force due to gravity from this bar, so there's going to be a force of gravity. And there's going to be some tension in the rope right there. And we know that the sum of the forces must add up to 0. Also, the sum of the torques must add up to 0. So last time what we did was we actually found the perpendicular force. But sometimes it's actually easier to think of it as perpendicular distance. So our equation is torque is equal to force times distance. And we put that perpendicular. But it's actually the same if I were to say torque is equal to force times distance perpendicular. The same thing, but it's a way of looking at the problem. So what before we approach this question, we must first recognize one thing. If I have a beam as this far or this long, so let me start again with that one. If I have a beam this long and I'm exerting a force on it to cause it to rotate, so it's pivoting around this point, like this force is going to cause this beam to rotate. However, what we can see in this picture is that force is not perpendicular to the object that is rotating. We know from experience, just if you want to get a feel for this, just go to your door and just try pushing at different angles. To get maximum effect, I would actually want to push it at this angle. But that's not the question. The question is showing us that we are pushing from this angle. So we're actually going to have the same effect of rotation as if we had a much shorter door and pushing downwards. So both these two scenarios, so they line up, will have the same torque, assuming this force is the same as this force. So assuming these two forces are the same, even though this arm is longer, because of the angle difference, they will effectively rotate with the same torque. They'll experience the same torque. So for this problem right here, instead of finding the perpendicular force, so what I mean by that is, if I want to find, here's our beam again. and our tension is in this direction. What is perpendicular to this? Perpendicular is actually this line right here. So it can be a little tricky finding the different values for t. So we actually want to find out what is this. I don't know, we can call this like ty or something. So we call that ty. But it could be a little tricky because what is that angle? Let's do a little bit of, we can do a little bit of trigonometry. You can say, okay, this angle right here, 0.43, 0.57, inverse tan, 0.43, divided by 0.57. The angle of 37 degrees. Therefore, if that's 37 degrees, this is going to be 53 degrees, and therefore that is 37 degrees. And we can see that ty is actually right there. That ty is going to equal to t cos 37 degrees. So again, we can go ahead, but again, this is still a little tricky because we say, okay, but now we have to do the same thing for, then we have to do the same thing for the other two forces acting on. So there's this force. Say, what is this perpendicular distance? We can find this. What is this? F1. And we say, oh, there's a force right here. There's F. We need to find out what the perpendicular force again. So we call that F2 or something. And you can see there's going to be quite a bit of like sines and cosines values before you can actually solve this. So instead of that, we can actually think perpendicular distance. So I say this is 0.50 meters. But what we're actually interested in is just this distance right here, because this distance from here to here is the perpendicular distance from our force F, center of gravity. And that's F, center of gravity. So we can go ahead and solve for that. Say, okay, what is the torque caused by FCG? So torque CG is equal to, you can say FCG multiplied by, so again, instead of finding the perpendicular force, I'm going to find the perpendicular distance. So that's going to be equal to 0.50 meters. And we can either write down sine 37 or we can use cos 53. So cos 53 degrees. Okay, that's solving for this solid black line that I just drew in. Now you say, what about the mass at the far end? Okay, torque of that mass at the far end. Let's call that torque of that mass. It's just the force of that mass. So I do 0.2 kilograms multiplied by 9.8. But we know the ruler itself is 1.00 meters. And that's also going to be cos 53 degrees. And lastly, torque of the tension is just equal to tension multiplied, and we've actually already found that perpendicular distance. That's the 0.57. 0.57 meters. So we're pretty much done. We just have different values. So what we can say to solve for this now is that the torque caused by the rope must equal the torque caused by the other two forces because those are opposing it. Okay. So let's just write this out. We're going to have torque here, so we have T 0.57 meters. And that's going to equal to the force center of gravity. That's 0.50 meters, cos 53 degrees, plus the force of the mass times 1.00 meters, cos 53 degrees. Again, we can solve for unknown, and we're done.